This is problem 5-68. We have a crank here turning and lifts up the weight, which is 75 kilograms. And it's got a support here, which will have it restrains it against movement in the X, Y, and Z direction. And we got a support here that restrains it in the BZ and BX direction. Those types of supports also can restrain some moments, but it says if the support is somewhere else, they're usually ignored. So we're going to ignore them. And if we don't ignore them, it's indeterminate and can't be solved. So let's redraw this real quick. Or let's just put it right here. So we got AZ, and we got AX, and we got AY. We've got 75 kilograms down, which is equal to 736 newtons. And we got a force here. We got BZ there. And we've got a BX there. So we have 1, 2, 3, 4, 5, 6 unknowns. We have 6 equations, and so this can be solved. I'm going to start by summing the moments about the y-axis. If I sum the moments about the y-axis, because you really don't want to end up with 6 equations, 6 unknowns. That's a mess. So we want to look for equations that we can solve with a few unknowns. And if we sum the moments about the y-axis, none of these matter, and neither of these matter. And we can just deal with this and the force. So summing the moments about the y, we got 736. And it has a distance there of 0.1. And that's causing rotation in the positive y. And then we got the force out here, which is causing rotation in the negative y. So we got negative F times a distance here of 0.2. And that equals 0. So F equals 368 pounds. No, not pounds, newtons. Now let's sum the forces in the y direction. So in the y direction we have AY, and that's it. So that equals 0. So now we've eliminated 2 of our unknowns. We've only got 4 to go. Next, I'm going to sum the moments about the x-axis. The x-axis right there. So if I sum the moments about the x-axis, AY doesn't matter, AZ doesn't matter, AX doesn't matter. So we do need this one here. So we got, and that's going to cause rotation this way. So it's hard to show the right hand in there, but that's going to be negative. That's causing negative rotation about the x-axis. So 736 times 0.6, that's negative. BZ is causing rotation about the x, and that's going to be in the positive. It's causing the opposite rotation of that. So plus BZ times 1.1 right there, 0.6 plus 0.5. And that equals 0. So BZ equals 401 newtons. Now let's sum the moments about the z-axis. So about the z-axis here, again, AY and AX and AZ don't matter. The 75 kilograms is in the z direction. It will not cause rotation about the z. BZ will not cause rotation about the z. BX will. So that's going to cause rotation this way, so that's going to be negative. So negative bx times 1.1 minus f will cause rotation, and the way that's drawn, it's going the same way. So negative f times, now this distance is 0.1 and 0.1 and 1.1, so it's 1.3. So that equals 0. Now f, as we already solved, is 368. And so bx is equal to negative 435. So this we actually drawn the wrong way. Oh, 435. Okay. Now let's we sum the moments about the y, the x, and the z. So now we got to sum the forces. Now let's sum the forces in the z. So in the z direction, we have AZ, we got BZ, and we got negative 736. Now BZ is actually 401. That equals 0. So AZ is equal to 335. Okay, so our last equation, we'll put that over here. Last equation is going to be sum the forces in the x direction. So in the x direction, we have AX, and we have BX. Now let's draw it this way. We could make sure we're doing it that way because that's how we had the negative. So plus BX. And we have F plus F equals 0. So 0 is equal to AX is, we don't know, BX, negative 435. Force, 368. And AX equals negative 67. That answer varies from the answer book. They have a different value here, and I couldn't follow what they did, so I think that's the right answer.